be talking about how to multiply and divide powers using integers. The very first problem I'm going to be doing is going to be doing the quotient property. I'll write this down. The quotient property states that if you have two variables of the same base, so a to the power of n over a to the power of n, these bases of these exponents are the same, you are allowed to subtract the powers of the exponents. So in this particular problem it says 5 to the power of negative 5 over 5 to the power of 8. So we are allowed to simply take these exponents and subtract them, which gives us 5 to the power of negative 13. Okay. So when it says rewrite the expression in form of 5 to the power of 10, the answer I'm going to do is 5 to the power of negative 13. To the power of negative 13. Okay. Here we are once again doing the quotient property. Right. So once again, if these terms have the same base value right here, these y values are exactly the same, I'm allowed to take these and subtract them. This is a little bit trickier. We have negative 7 and we have to take away a negative 13, which means we have a negative and negative, we've got to add. So our answer is going to be negative 7 plus 13, which gives us y to the power of 6. All right, 1 second. This right here, this is the product property. You'll notice these terms are being multiplied. Okay, so this is called the product property. So I'm going to write down the rule for what's called product property. That's if you have two terms being multiplied together and have the same base. These numbers are exactly the same. You are allowed to add those exponents. So this would be a to the power of n plus n. Now, just do a quick little example. If I said 2 to the power of 4 times 2 to the power of 3, why is that 2 to the power of 7? Because 2 to the power of 4 is 2 times 2 times 2 times 2. And 2 to the power of 3 is 2 times 2 times 2. And when you count them all up, how many 2's are being multiplied to themselves? A total of 7. That's why you're allowed to add your exponents. Okay. So all I'm going to do right now is take a negative 8 and 3, add them together. That gets 8 to the negative 7. Alright, so I'm going to put 8 power of negative 5. I'm going to quickly go over what negative exponents mean before I type this in. You're wondering, what is a negative exponent? Let's just start with something you should know. Okay. You should know that 2 to the power of 0, any number to the power of 0 is 1. Why would that be the case? You do the quotient property. If I have 2 to the power of 1 over 2 to the power of 1, everybody knows 2 divided by 2 is 1. But if I use the quotient property, I'm allowed to subtract these. I'll do 2 to the power of 1 minus 1, which gets me 2 to the power of 0. 2 to the power of 0 is 1. If I say 2 to the first, you probably know that's 2. You probably know that 2 squared is 4, and 2 cubed is 8. I'll stop. Let's go backwards. What if I said 2 2 to the power of negative 1? What's 2 to the power of negative 2? What's 2 to the power of negative 3? This is where students get confused. Okay? Because negative exponents have nothing to do with making a number negative. It's about writing it as a smaller number. So right now, 2 to the power of negative 1 is the same as 1 over 2 to the first. 2 to the power of negative 2 is the same as 1 over 2 squared. And 2 to the power of negative 3 is the same as 1 over 2 cubed. This becomes 1 over 8. This becomes 1 over 4. And this is just 1 over 2. So we should look at the pattern real quick. I have a 1, then I go to 2, 4, 8. Well, this just becomes 1 over 2, 1 over 4, 1 over 8. Okay. So negative exponents help us talk about really small numbers as we're approaching, getting closer and closer to 0. Go do 8. So something you need to understand, if I say 8 to the power of negative 5, that is the same as saying 1 over 8 to the power of 5. Now 8 to the power of 5 is a big number. That's 32,768. So this would be 1 over 32,768. Okay? That, if we had to evaluate this, if I said evaluate this, this would be the answer because it evaluated. But it just says put it in the form of 8 to the power of n. So we're just going to write 8 to the power of negative 5. Okay, when we add those together, you get negative 11, you get negative 15. Add them together, you get negative 26. Which is c to the power of negative 26. Okay, and before I move on to the next topic, I just want to make sure you guys understand that if I wanted to rewrite this as a positive exponent, all I have to do is shift it down in the denominator. These mean the same thing. These are the same thing. So we're going to do something else. We're going to do powers of products. So this is going to be something called the power property. Okay? And the power property is different than the product property and the quotient property. Okay? We're going to quickly review all three of them. All right? We're going to talk about the product, the quotient, and the power property. Let me give you 3 examples. Okay? Here's the product property once again. Here's the quotient property. And here's the power property. I'm going to give you some base numbers here. We got 2 to the power of 4 times 2 to the power of 10, which gives me 2 to the power of 14. If I say 2 to the 17th power over 2 to the 20th power, this would be 2 to the power of negative 3, which would be the same as saying 1 over 2 cubed, which would be 1 over 8. Okay? If I wanted to evaluate all the way to the very end. Right now, I'm just going to keep it as 2 to the power of negative 3. But if I said 4 to the power of 3, and I said to the power of 5, this is the only time you're allowed to multiply your numbers together. So this would be 4 to the power of 15. That's the power property. You are allowed to take these numbers and do what with them? Multiply them together. That's the power property. So if I go back here and take a look at our problem. Alright. So right here we're doing the power property, which means I'm allowed to take these powers right here and multiply. So I'm going to rewrite it a little bigger. Okay? 3 to the power of negative 6 over 7 to the power of negative 3 to the power of 5. I'm allowed to take this power and multiply it to this power and multiply it to this power. So this gives me 3 to the power of negative 30 over 7 to the power of negative 15. Because 5 times negative 6 is negative 30. And 5 times negative 3 is negative 15. Now, there's something special about negative exponents. If you ever want to make them positive, all you have to do is shift them up or shift them down. So if I shift this up, that becomes 7 to the power of 15. If I shift this down, that becomes 3 to the power of 30. So if I ever want to make a negative exponent positive, just shift it either down in a denominator or move it up to the numerator. Okay? So now this is going to be my final answer. That's what I'm going to be looking for. Okay, right there, 7 to the power of 15 over 3 to the power of 30. Right here. All right, here we go. I'll do another power property one. Okay, do one more power property. Here we go. It says a to the power of negative 3 over b squared to the power of 4. Yep. So we're going to take this power and multiply to this power and multiply to this power. So this is going to be a to the power of negative 12 over b to the power of 8. Now, I need you to understand, if I have a negative exponent and I want to make it positive, I can move it down. If I move this down, now in the numerator, I have a 1. I have a to the power of 12 in the denominator and b to the 8. So right here, this will be my final answer if everything is positive, which is going to be answer choice B. Why didn't I move the b to the power of 8? It was already positive. I don't need to move it. I can just stay right there. Okay, so I just move this down in the denominator, and there's a 1 right here. Just remember, a to the power of negative 12 is the same as saying 1 over a to the power of 12. So it means the same thing. Okay, here we go. Last one of the power property. It's 3 to the power of negative 8 times 7 cubed, close parentheses, all to the power of negative 2. What are we going to do with this power? With this power and this power, we are going to multiply them. So we have 3 to the power of negative 8 times negative 2, which is 16, times 7 to the power of negative 6. But oh, this is a negative exponent. So what do I need to do? I need to change it and make it positive. So all I'm going to do is put it down in the old denominator. Okay? So right here, if everybody sees, this is the correct answer. But I can also have 3 to the power of 16 over 7 to the power of 6. This would be another answer that would be correct. So the answer is going to be A, but they could have put a different answer and written it like this, and this would also be an equivalent answer. Okay. And last but not least, we're going to go one more challenge problems. Okay, let's see how challenging these are. All right. So right now it says, which of the expressions are equivalent to 7 times 7 times 7 times 7 times 7? Well, what is that equivalent to? That's equivalent to 7 to the power of 5. Now, if I do this problem, what am I allowed to do with the exponents? I'm allowed to subtract them. 8 minus 3 is 5, so that works. If I do 7 to the power of 5 times 7 to the power of 1, that's actually 7 to the power of 6. So that's not it. And this is definitely not it. So this does match because 8 minus 3 is 5. 1, 2, 3, 4, 5. The answer is A. Okay, so look at this one. This right here is 1/5 multiplied to itself 4 times. So that's the same thing as saying 1 over 5 to the power of 4. are two equivalent expressions. Okay? So what are we looking for? We're looking for 1 over 5 to the power of 4 or 5 to the power of negative 4. Ooh, power property. I can multiply those together. That becomes 5 to the power of negative 4. So answer A works. What's anything to the power of 0? Hopefully you know anything to the power of 0 is 1. Okay? Now watch. Let me just show you. If you don't believe me, watch this. I bet everybody watching this video, which is nobody right now, but if you're watching this video, you would love to have that in your bank account. You know, it'd be awesome. But then watch. I raise that to the power of 0. Hold on. You're done with it. What about negative numbers? What about negative numbers? Raise that to the power of 0. 1. Any number raised to the power of 0 is 1. So this is just a 1, so that's not it. Okay? So the answer is going to be answer choice A. Okay, here we go. So now we have 7 to the power of negative 3 divided by 7 to the power of negative 1. Using the quotient property, we're going to do 7 to the negative 3 minus A, negative 1. One thing I'm really proud of my daughter doing algebra right now, every time she sees a minus and a minus, she always puts a little parentheses. It makes me really, really happy. But I don't have to tell her, she just does it. Negative and negative makes it a positive. So I get 7 to the power of negative 2. And 7 to the power of negative 2 is the same as 1 over 7 squared. So that's the right answer, and that's the right answer. So what you have to really know to do these problems, you have to know these types of rules. You have to know three of them. You have to know the product property. You have to know the quotient property. And you have to know the power property. And I'll do them one more time. A to the power of n times A to the power of n is A to the power of n plus n. The quotient property. If you are dividing, you are allowed to subtract the exponents. And last but not least, if you have a power to a power, that is the only time you are allowed to multiply the exponents. And last but not least, you need to know that negative exponents are just simply, if you want to make them positive, we're just simply placed underneath the 1. So the answer to this is going to be A and B. And that's all I'm going to do. I'm tired of doing these problems. Alright, they're easy.